All right, let's take a look at one. Let's do f of x. I guess we could say y. Doesn't really matter. Sine of x. Okay, so we got f of x equals sine of x. Since I don't know if anybody knows what these look like, and texting your friends won't give you the answer either, let's go ahead and just plug in a couple points just to see exactly where it is. We'll just do an XY chart and see what that looks like. Now, the classic points that I would plug in, let's see. First, I would plug in all the points that we did on all of our circles from chapter 6. I know it's probably been a little while, but we did all of our SOHCAHTOAs, the pi stuff, and the 0, 90, and 180, and 270. But they're all in pi's, right? They're all in terms of pi's. So we're going to actually use those for today. We're going to start at 0. If I go up to 90 and plug in 90, 90 is the same as pi over 2 as far as the values for us. I'm just picking different points. Yeah, 0 and then pi over 2 is another point, and then you do this if you want. And the next one's pi, yeah. And then the next one was 3 pi over 2. And then the last one was 2 pi. And once you get to 2 pi, you're basically back to 0. So you're kind of repeating yourself and going over and over again. The reason that we have to use this in what they call this radian form, which we've done before. The reason they use radian form is because I'm eventually going to graph this, right? I'm going to eventually put it on a graph. And I don't know where to put 90 degrees. Like, that's kind of a weird thing to graph on an XY chart. Or 270 degrees. It's kind of weird. But pi over 2 is an actual number, right? If you were to put pi over 2 in your calculator, we'll throw this up here. If I were to do pi divided by 2, it's an actual number. It's 1.57. So I can get pretty close and say, all right, well, if this is 1, 1.57 will be right about there. So we can all graph that. This is actually considered a length versus degrees, just some sort of angle. So we want to type this in our calculator and just see what we get. Okay. So the first one is we're plugging the 0 right there. So we want to figure out what the sine of 0 is. Okay. So let's go ahead and do the sine of 0. Everybody get 0? Out. And we're just going to plug in these 5. Now, we're not going to do this every time, so don't feel like you have to know how to do this on your calculator. But it's kind of nice to check your answers. Pi over 2, let's say we do the sine of pi divided by 2. Ooh, 0.027. Kind of grossness, right? Now, my mode right here, I'm in degree mode. If you notice right here, it says degree, right? Degree mode. And these are all radian numbers right here. So what you want to do is you want to either switch your calculator to radian or think of these in degrees, okay? I would switch your calculator if you were going to actually be testing these out. So go ahead and change your calculator to radian. And your calculator screen will look a little different than that. Most of you have like a button that might say like a DRG, or it might be in a submenu or something like that. So you might have to hit like mode. You might have a mode button. Every calculator is a little different. The ones like this, a fair amount of you have ones like this. There's a button that says DRG right on the top there. Some of you have that button. Okay. Some have calculators like this. And there's a mode button. You hit mode and decide which one it is. Some people have a calculator like this. And if it's one of these, then once again, I think you hit the mode, and then it actually tells you which one is radians. So it all depends on your calculator. If you can't get it just in the right mode right now, I can show you later how to get there. Say it again. We're just going to keep it radian for all of them, exactly. So if we're just in radian, then we're happy, okay? And so let me try the sine of pi over 2 again. Pi divided by 2. Ooh, that's a better number. 1. I like that. It's magically 1. Isn't it so good? Magically. 2 ways I can explain it to you. One is go back to that unit circle, which is grossness and ugliness, and I'd rather not. The other is if we tried to build a triangle around pi over 2, which is straight up, we would build that triangle that's kind of weirdly just off the line. It would end up giving us 1 when we did that. So, anyways, so now we're going to do pi. Okay, so let's go and do the sine of pi real quick. Sine of pi is 0. Back to 0. We'll do.
Okay, never mind. Well, I don't want to ask.
Well, the thing is I'm going to give you the answer, and you're not going to want to hear it anyways. I have a feeling. So.
Yeah, I just give up.
Yeah. So, but I will. If we were to do sine of pi over 2, right? Pi over 2 is straight up right here. This is pi over 2. So that's if I were trying to build a triangle around that, which is that weird triangle right there, where this triangle doesn't exist. This line's all the way on that line, which means these sides are both the same. Those are 1s, and this was 0. And if I do the sine of this angle right here, it's opposite and hypotenuse. Opposite 1, hypotenuse is 1. So 1 over 1. So that's why that's 1. I got that look that I knew I was going to get. That's why I didn't want to answer that question. Okay, so back to this. So we got 3 pi over 2, so let's do sine of 3 pi over 2. Ooh, negative 1. Okay, I'm going to put that in there. I'll do it. 0. So then the last one, 2 pi. Well, 2 pi and 0 are the same spot as far as circular on that one graph, right? 0 and 2 pi. You start repeating yourself. So let's go ahead and graph those points real quick. So I'm going to graph the first point, 0, 0. That's an easy one. Just put it right at the origin. Now we're going to go out pi over 2. Now pi over 2 is 1.57. If you're not exact, it's not a huge deal. You're going to come out here and put a mark out there, and you're going to call this mark pi over 2. That way it's exactly on that mark. Okay, this is 1.57. Yeah, it might not be to scale, but close enough. Okay, you can make up your own scales, whatever you want. Anything you want on the x-axis, you can do. Okay, you read the newspaper all the time. They always have different numbers, and it's not like they go 1, 2, 3 on all the graphs they ever put in the newspaper. So anyways, pi over 2. When I go up pi over 2, I go up a value of 1. So I'm going to go up here to 1, and at pi over 2, I'm up 1. So there's 1 point right there. Okay, now the distance between 0 and pi over 2 is what, 1.57 or whatever that is? The distance between pi over 2 and pi is the exact same distance, okay? So I'm going to go out another even increment, which, once again, I'm making up my own increments, but I'm going even increments all the way out here, and I'm going to call this increment pi. And then when I'm at pi, I'm back at 0. So I've got this point right back at 0 again. Okay, when I go to 3 pi over 2, which is another even increment out, so I'm going to go another even increment. Notice I'm trying to space those really nicely. I'm going to negative 1, so I go down here to negative 1. That point's going to land right here. And the last one's 2 pi, yet again another even increment going on out here, and then right back to origin, so it's going to look like that. Okay, now all you have to do is connect the dots, nice smooth curve between those, and you're good to go. Okay, so we're going to graph something like this. Okay, and they call this a sine wave or a sine curve, any one of those. Okay, you've probably never seen these before. You might have seen like maybe part of a parabola, possibly.
Didn't we do those one with the baby graphs thing? We did like that.
I don't think we've ever graphed these before.
Or maybe not this, but a graph like that. Well, we did like that increase thing.
We did like exponential growth.
Yeah.
But that's just where it went like that or went like that.
No,
We
we
were gonna
did
check
that one wave thing.
Oh, it's not now.
That's the first one.
So anyways, as I graph it on the graph calculator, it looks exactly the same as what I have. Now notice what I have right here on my board is only one part of the graph. Notice the graph continues forever because these are cyclic functions. They repeat themselves over and over again. Okay? The gap from here to here, this one cycle, they call this one cycle or one period. One period or one cycle. And you can call it whichever one you want. I'm usually going to use the word period because the book will ask you often for what's the period of this function. Basically, it means how far is this graph going before it starts repeating itself. Now, the nice part is I've graphed one nice little section of this. They might say graph this continuously, which means just cut and paste this part of the graph. We're just going to copy this on the other side like this, and on the other side like that, and it goes on forever in both directions. Okay? Now, we only have to find, oh, I didn't label here. I'm sorry. I should have labeled. This is 3 pi over 2, and this was 2 pi. I apologize. You need those labels right there. Okay? Say it again. You guys are smart. You got to figure it out. Okay? But from here to here, this is considered to be the cycle or the period of the graph. That's how far it goes before it starts repeating itself. Okay? The other big thing we want to find out is what's called the amplitude. Amplitude. Science. Amplitude. What do you think the amplitude means? It's like the height. Exactly. This is like the height of it. Okay? So what's the height of that guy? 1. From its center, from its basically its resting place right here in the middle, we're going to go up 1 and we're going to go down 1. So my height here, amplitude is going to equal 1. Okay? Now, there's 5 key points. Whenever we graph these, we don't want to do a t-chart. We want to avoid that at all costs. Okay? We don't want to be plugging in values all the time to try to figure out what numbers are. Plus, it's not always going to be these X numbers. Okay? These numbers are going to change. It's kind of like, when we start at -2, -1, 0, 1, 2. Those don't always work for all the graphs. Okay? So this is only going to work for kind of our starter graphs that we're doing. Okay? So a couple key things we're going to do today. One is the amplitude, tells you how high it is. And the other is the period, tells you how far it goes before it starts repeating itself. Okay? The sine function goes up, and then goes back down, and then starts right back here again, and then it starts repeating itself again. It does that over and over and over again. Okay? So for the sine function, let's go ahead and look at the generic sine function real quick. My generic looks like this. Y equals, it can be f of x, equals a sine b of x. Okay, this will be our generic sine function. Okay, now there's a in front. You know, I guess what that stands for. Amplitude, exactly. This is your amplitude. Okay, it tells you how high it goes. And it actually has to be the absolute value of a. I'll explain that in a little bit. That'll make more sense in a second. Okay, but I want to take the absolute value of whatever the A value is. Okay, so whatever number is in front of there, that's my amplitude. That tells me how high and how low the graph is going to go. Okay, the period on this one actually has to do with this B. It's the number that's right in front of the X right there. So if I were to look at this graph, what was the period on this graph? How far did this guy travel before it starts repeating itself? How far is it from here to here? 2 pi, right? 2 pi is one cycle or one period of this, okay? So I travel a gap of 2 pi for this particular one, okay? So my period on this is actually going to be 2 pi. Nice part, it's always going to be 2 pi for what we're doing, divided by whatever the B number happens to be.
Wait, period is B?
The period is always 2 pi divided by B, whatever that B value is. Okay? So if I put a number there, that's going to basically accordion the graph. It's going to either squish it in or it's going to stretch it out, one of the two. If I put a number in the front, that's going to stretch it up or squish it down, one of those two. So you should have or both. Exactly. So for like the one we just did, right? Our basic function, it was y equals the sine of x, right? Well, what's the coefficient for this guy? 1. What was the amplitude on that graph? 1. Okay, what was the coefficient for the x right here? Technically, there's a little 1 in front of there, right? Anything has a coefficient of 1, right? So if nothing's there. So my amplitude was actually 2 pi. I'm sorry, my amplitude was 1. My period was 2 pi over 1. But 2 pi over 1 is still 2 pi. So that's why that period happened to be 2 pi on the first one. Okay? So let's go ahead and change those real quick, and I'll show you kind of how I want us to graph these problems. Because I don't want to have to go through this every time. That's kind of a mess. Yep.
What's the graph look like if you're not in radian?
It's kind of weird. It's kind of like weird lines here. It also depends on which graph you're doing. That's all you get.
It keeps moving.
We can try to do that. See if that helps.
It's a 45-degree angle.
Doesn't like it. The modes don't jive too well. So we have to. Anyway, now that's super zoomed in. It's hovering right on the axis for that one. But yeah, we need to be in the right mode here. So we'll change that to that mode, and then we'll go zoom 6er, and we should be back again. Okay, cool. So let's go ahead and change this just a little bit. Yeah.
Multiply by a whole number to make it get bigger, right?
Correct.
Okay.
Correct. All right. Can I erase this? Everybody have that? Okay, good. Okay, let's go ahead and tweak this just a little bit now. Let's go ahead and say we have y equals 2 sine of, how hard do I want to go? Really hard. 7 would be hard. We'll do 7 later, I promise. But for now, let's try to keep it a little easier.
Try not to make it run further than easy.
Yeah. We got to do cosine still too, so we got a fair amount to do. But it's all good. Cosine's not too bad. Once you know sine, you'll be good to go. Okay. Now this is what I would do. Okay. There's 5 key points that you want to find for a sine function. What you want to know is you want to know the generic, what a regular sine function looks like. It's like, you guys know what a parent function of a parabola looks like, right? It's just the U-shaped guy. You know absolute value, you know lines, you know the cubics, you know a bunch of those, right? For sine, you know the sine curve is going to look something like that. Okay? So I always draw a little mini curve just up in the corner and say, all right, my graph's going to look something like that when I'm done. Okay? There's 5 key points I want to find. I want to find these 5 right here. Basically, I want to find the 2 endpoints. I want to find the center of that, and then I want to find what they call the maximum and minimum, the high and the low points for those things. Okay? So I want to find those 5 key points. So first thing you want to do is figure out what the amplitude is. How tall is this guy going to go? Right? 2. Okay? The amplitude is 2. Technically, it's the absolute value of 2, but it doesn't change it, right? We're good there. Okay, the period on this guy, what's the period?
2 pi.
Just pi. 2 pi over 2. It's 2 pi over the number in front here. Okay, so this is going to be a 2 pi divided by 2, which happens to be pi. Okay, so what that means that the graph is going to get stretched up to, and it's going to get squished in, because it's going to fill in a whole entire period inside of a gap of pi. Okay, so this is how I would graph it. This. First off, start with your little graph right here. For the sine function, the first one is at the origin. We don't have to do anything crazy with it. It starts at the origin. I'm going to put a point right at the origin. All right, cool. You got 1 of 5 points done. Okay, the other 4 are what we have to find. Okay, what I do is I jump to the end. I jump to the very end because I know this gap right here. I know how far it is from here to here, right? What's 1 period for my graph? Pi on this one, right? Because my period got changed. So I'm going to go out to pi. Now, you're going to go out as far as you want. It doesn't matter how far you go. I'm just going to guess and call that pi. Okay, I'm making up my own increments, so who cares? I could have put it way out here, and it might have looked stretched, but it's not. Okay, if you want to be exactly precise, make it precise. Pi is about 3, right? So you can ballpark it to about 3 if you really, really want to. Okay? So pi is my first point, or my last point, and it's on the axis. So I'm going to graph this point on the axis at pi. Okay? And I don't want to plug in any points. I want to do this without a calculator pretty much. Okay? Now what I do is, now that I've got the two endpoints done, I'm just going to put a little X through them. Those are done. I want to go to the center of this guy. Now the center happens to be right in the middle of the two endpoints, right? So if I just cut that little thing in half, my middle point is going to be right on the axis, and it's halfway there, right? Well, what's half of pi? Pi over 2. Yeah, you're right. Pi over 2. Okay, I just divide that by 2. So pi over 2 is my middle increment right there. Okay, so I got the middle point checked off now, so this guy's good. Now let's go ahead and find this little maximum point right here. Okay, the maximum point is right in between the center and the first endpoint. I'm just going to split that in half right there. And I'm going to go up the amplitude. The amplitude is up 2, so I'm going to go up 2 and put my point right there. Okay, now what would my x value be right here? Pi over 4. The nice way to cut that in half is just double the denominator. Okay, so if this is pi over 2, just go pi over 4 to get to here. Okay, usually these ones are the easiest ones to find. Just so you know, this one is the bear. This one's the tough one out of all. Okay, move this up just a little bit.
But we have to label it.
That's what I'm grading. I'm grading for your labels, and I'm grading for the graph being in the right spot. That's what I'm looking for. So you'll get half credit for your labels, half credit for the graph being in the right spot. Okay, the last point on my little mini graph is this point right here. Okay, and that's in between the center and then the end point, right? And it's down at the amplitude. So if I go here, I want to cut this in half, and I want to go down the amplitude, which is -2, and I'm going to go down right there. Okay, I've got my sine function now. Let's go ahead and graph it. And then the last thing we have to do is find this little point right here in the middle, which is going to be the toughest part about it. Okay, that's the average of these two. Okay, it's right in the middle of those two, so I just have to average those two. Okay, so if I average those two, how do you average two things? Add them together and divide by 2, right? So I have to add these together and divide by 2. So I'm going to go pi over 2 plus pi, divide all that by 2. Okay, so I have to add those two together and then divide it by 2. This will give me the average between those 2 points. Okay, so to do a common denominator, I need a common denominator, right? Let me move this pi over just a little bit. I need a common denominator to add those together. So this guy needs to be a 2 and a 2. So my numerator here is going to be a 3 pi over 2 divided by 2. Now, if I take 3 pi over 2 and I cut it in half, right, I can just double that denominator. Okay, so this would be 3 pi over 4. So this would be 3 pi over 4. We'll do a bunch of these. So if that didn't click right away, it's okay. We're going to do a couple more. Okay?
3 pi over 4.
Should be 3 pi over 4. Because if I add these together, I get 3 pi over 2, and then I got to cut that in half.
So is it
Okay?
always going to be 3 pi over something?
Nope. Nope. If you pick a 7, it'd be gross. But that's okay. We'll try that one. Okay. All right. Now there's another way to do this if you want. There's a kind of a counting principle. Okay, and that is if I have 1 pi over 4. This is 2 pi over 4, 3 pi over 4, and 4 pi over 4. Reduced, right? 1 pi over 4, 2 pi over 4 reduces. Pi over 2, right? 3 pi over 4 doesn't reduce. 4 pi over 4 reduces to pi. Okay? So you could actually do kind of a counting idea there if you want as well. Yep.
Is the first number always going to be the right? Like, is that one always going to be the right denominator for the third one?
Not necessarily. It could actually. You could, but this might reduce actually. There's potential of this reducing, so it might not be the same.
That's the largest one possible.
But that would be the largest one. I don't know about that one. I want to say maybe, because I honestly don't know. I know. I'm curious about that now. We got to pick a hard one and then try it.
7.
We'll do 7 in a second. Yeah, let's do
So the
7.
bigger it gets, the
I think we're getting the general idea, maybe, right? Kind of.
So the bigger the number gets, the harder it gets.
basically,
One more of the signs, and then we'll change it up to the cosines. Okay?
basically, the 3 points are exactly the same. Right?
Basically.
Yeah, because you said that all the ones on the axis. Are those always going to
Oh, those are always good for now.
Yeah.
For now.
Okay, so the bigger the number gets, the harder it gets. Or the
Yeah.
closer it gets.
Yeah. How hard do we make this one?
15.
9, 2, 3, 4. 7 is the chicken number.
It's gonna be gross. It's gonna be gross. Maybe this will answer our question. Maybe. So I don't know the answer. Nobody's ever asked that one before. All right, so let's go ahead and first figure out what the what I'd like to do is do a little mini sine. Mini sine goes up, down, and back up. There's 5 key points that you want to find. Okay, we're always going to be finding those 5 key points. The nice part is the main 3 are going to be on the axis for the sine function. Those will be pretty easy to find. Okay, the amplitude is 3, and my period. Ooh, I better write this down. The amplitude is 3, and my period is going to be
2 pi over 7.
2 pi over 7. Awesome. That's a good one.
Yes.
2 pi over 7. Kind of nasty, but we'll get through it. Okay. So let's go ahead and graph this. Doing my sine function. Okay. Now for the first part, the first point is right at the origin. That's an easy one. For the sine, you get a free point. Okay. Right at the origin. The last point is at the end of my period and on the axis. So I'm going to come out here somewhere and go right on the axis and put my point down. Okay. Now how far is my period? How far did I travel? 2 pi over 7. Okay. So my increment right here is going to be a 2 pi over 7. That's my increment. Okay. Now I just average. The rest of this is averages. Okay. I'm just going to split this in half. Okay. So I split that in half. It's also on the axis. And then what's my increment right here? 2 pi over 14. Now I think that reduces, doesn't it? Pi over 7. Good, good. Pi over 7. If that's 2 pi over 7, half of it would be 1 pi over 7. That should make a little bit of sense, I hope. But if you left it as 2 pi over 14, you'd be fine. I wouldn't mark it wrong, okay, if you didn't reduce those, okay? But this would be pi over 7, okay? Now I'm going to split that in half, and that's up at the amplitude. So I'm going to go up 1, 2, 3, and up 3. And I'm going to split this guy in half, so what's half of pi over 7?
Pi over 14.
Pi over 14, okay, just double the denominator.
I'm just split it twice.
Okay, now the tough part is getting this bottom, this last 5th point's always the toughest one to do, okay? At least you can graph it. Got that point, at least know where it is, right? Now we just got to find out what that increment is. Well, we add these together and divide by 2, okay? This one's actually kind of easier, I hate to say that, just because it reduced earlier. So this is pi over 7 plus 2 pi over 7, and then divide that by 2. Okay, I'm averaging these 2 points right here. Add them together, divide by 2. Now if I add those together, I get 3 pi over 7, right? And then I divide that by 2, it gives me 3 pi over 14, which doesn't reduce. Last I checked. Okay? You could also use kind of a counting principle here. Once you get to pi over 14, it's 1 pi over 14, 2 pi over 14, 3 pi over 14, 4 pi over 14. You can also count, okay? So that helps a little bit. Now be careful when you count. You got to make sure you get from here to here that your first step is good before you go to your next one, okay? Because it might not always be perfect. Say it again. We got actually kind of lucky that it reduced right here, believe it or not.
You should have done like 30.
It's going to get gross when we start moving the graphs left and right. That's going to get nasty. Just wait, it's going to happen. Not today, not today. But. Okay, so there's my sine function. Now that's 1 period or 1 cycle. I want to do multiple periods of cycles. I can just basically copy that, copy it here, be done. Questions? Yep. No. When I add these together, my denominator stays set. When you add things with like denominators, you don't change the denominator. Yeah. So if I add, but ignore the 2 on the bottom, right? What do those 2 add together to? Okay, divide that by 2. Basically double the denominator, right? So if I double the 7 now, that gives me 3 pi over 14, right? And so that's where that value came from, okay? So, all right, cool. So that's the sine function, okay? Now we got to do the cosine function, which is equal as far as difficulty level, okay? Now we're not really sure. What's that? Yeah. Okay, let's go ahead and start with our basic y equals cosine of x. Okay, and on this one, I hate to do it to you, but we better do a quick xy chart. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so those are my values that I would plug in. If I were to plug them in, I'm just going to give them to you now. It's going to be 1, 0, -1, 0, 1. Okay, so those are the values that I would get if I were to do it. Almost. If I were to graph this now, this is my basic cosine function. 0, 1 is my first point now. So now it's 0, 1, it's way up here. So it doesn't start at the origin anymore. Okay, cosine doesn't start at the origin. I go out pi over 2, and I go to 0. I go to pi, it's at -1. I go to 3 pi over 2. Oops. and that's back at 0. And the last one is on 2 pi, and back up at 1. Not a problem. Because it continues forever, right? So what's the difference between this and a sine function? It starts at a different spot. It just moved over a little bit. Okay, the sine function is here, right? It starts at the origin and goes up, down, and back up. The cosine just moves over a little bit. Okay, so the only difference between sine and cosine is the little move. Okay, amplitude is the same, period is the same, all of that stuff is the same. The only thing you change is your mini little 5 points that you start with. Okay, so when I draw this little mini sine graph, it looks like this. Okay, I'm going to draw a mini cosine graph, and I'm going to graph those 5 points using a little mini cosine graph. Okay, so let's go ahead and do one. Ready to make this super hard? How hard should we go here? Let's go. I don't want to go too hard. Okay, let's go ahead and do. 2 cosine of 4x. It's all that's the same. Yep, nothing changes for sine or cosine. They are identical. And I know people are going to want to pack up, but hang on tight. That's fine. That's fine. Just all the noise drives me out. Okay, so amplitude for this one, amplitude should be 2. Period should be 2 pi over 4, which is pi over 2. Okay, so my amplitude is pi over 2. Or, I'm sorry, period is pi over 2. And I'm doing a cosine graph. The cosine graph starts up, goes down, and then finishes back up, and there's 5 key points that you want to find. Cosine looks like a V. Then it'll just continue on both sides. Okay, so for our cosine graph, it now starts at the amplitude, so it's going to go up 2. There's my first point. I go to the end of the period, just like I did on the sine function, go to the last point, so come out here somewhere. That's going to finish up at the amplitude now, instead of being on the axis like the sine was. And then this value right here is my period, so it's going to be a pi over 2 for my period right there. Okay, we'll split that in half. What's half of pi over 2? Pi over 4. Okay, what's half of pi over 4? Pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. Okay, now let's go ahead and graph our points. We have the one in the middle here was down the amplitude, like so. And then we have these two are actually on the axis, so they're kind of freebies. Okay, so those are the ones in the middle. Okay, we've got our graph, and we're done. Okay, so as you kind of get the idea, these graphs start to go pretty fast. Okay, as you start to see what the amplitude and period were. Okay, don't pack up yet. Any questions so far? We're good? Yeah.
Does cosine always start at 1?
Cosine, no, cosine always starts at 0 and whatever the amplitude is.
Oh.
Okay, the amplitude was 2, so I went up 2 on this one versus the last one. Okay. All right, now, real quick, a couple curveballs real quick. What if I threw a negative in the front there? And flip it over, okay? So take this graph and you just flip it on over, okay? Does that change your amplitude? No, it's still 2. That's why that absolute value makes that a positive 2, okay? So it would start down 2, go up, and then finish back down, okay? Now, it gets real tricky is what if I had this? What if I had cosine of x over 2? What's the period on this guy? It's kind of gross. Period is always 2 pi divided by the number in front of the x, right? What number is in front of the x on this one? A 1/2. There's a 1 right here, and the divide by 2. So that whole thing is the thing. So it's 2 pi over 1/2. Ooh. What happens when you divide by a fraction? Multiply by its reciprocal. So this would equal 4 pi. Okay, so my period for that one would be 4 pi. Which your increments on that one are going to be super easy, right? 0, 4 pi, 2 pi, 1 pi, 1 pi, 2 pi, 3 pi, 4 pi. It'd be awesome. I apologize for going on the bell. I don't do it very often. 495, 1 to 13 on 35 to 40.
Yeah.